Operations and sets. This time, we will illustrate the union and intersection of sets, complement of a set, and the difference of two sets. And we will be using Venn diagrams to represent these set operations. So allow me to give you two different sets. Our first set would be about Sandra's favorite fruits: apple, mango, and banana. So we can write that in raster notation with the name of set A. So set A containing the elements apple, mango, and banana. And for our second set, we have Marco's favorite fruits. We have orange, pineapple, and mango. So we will represent this set as set B. And again, we can write it in raster notation just like Sandra's favorite fruits. B containing the elements orange, pineapple, and mango. What fruit do they both like? Yes, that's correct. The answer is mango. Actually, the answer mango represents the intersection of the two sets. And this will lead us to the definition of intersection, in which the intersection of sets A and B written in this format now, so we can write it um, sh- in a short statement by using the symbol. So it's like an inverted U. So A intersection B is the set containing the elements that are in both A and B. So again, every time that you see this symbol, it means that you need to find the common elements that are in both A and B. So later part, when we try to solve for word problems, remember that when you encounter the word and, it refers to intersection. If we will use Venn diagram to represent the intersection, this is the region where you place the elements which is common to both in our two elements. So let's try to consider the example about Sandra and Marco. So don't forget that you have to start with a rectangle to represent the universal set. You label it with a U on the upper right. And then two circles that overlaps. The A is for Sandra and B is for Marco. So the very first thing that we have to do, we have to place the elements on its correct region. So remember that this region in here, okay, let me just use a highlighter. So the region in here is intended for um, the fruits that Sandra likes, but not Marco. In other words, Sandra's favorite fruits only. So we commonly use the word only to indicate that that certain element is not shared in other set. So for example, Sandra loves apple and banana, but not Marco. Next, if we try to use this area now, or the region, this is where you will place the fruits that Marco likes, but not Sandra. So we have orange and pineapple. And the overlapping area or region of the two circles, this is where we place the common elements of Sandra and Marco, or in other words, the intersection between the two, in which we answered mango. So I repeat, do not forget that this area in here, okay, let me allow me to use another color to highlight the region. So here, so this is for the intersection of the two circles. So if you notice, the mango is inside the circle of B as well as the circle of A. That will give us a message that they both like mango. So now, what if we remove the mango in both sets? So like this. In the Venn diagram, the mango is in the middle. But what if we remove that? That means that we need to correct our Venn diagram because it's wrong. If they don't have anything in common, that means that we need to separate the two circles. Because if we completely separate the two circles, that means that they are disjoint sets. So how do we know if they are so-called as disjoint sets? When you try to get the intersection of the two and there are no elements, that means it's empty. It shows that the situation is a disjoint sets. So just remember, if the two sets given to you doesn't have any intersection at all, therefore it's empty, meaning they are so-called as disjoint sets. And in Venn diagram, the two circles should not overlap with each other as an indicator that they don't have anything in common. So let's try to have this example. The students who love swimming are in S, and those who love football are in F. So we have two different sets here. Those who love swimming is June, Ben, Arthur, and Simon. And those who love football, we have Carlos, Miguel, June, and Ben. So always remember, how do we read this? We can read it as the intersection of S and F, or S intersection F. I repeat, the intersection, you can start by reading the operation first. By the way, this is a set operation already, the intersection. Start with the operation, okay, set operation, then left to right. Set the intersection of S and F. Or you can just read it from left to right as S intersection F. So our answer here, we're looking for the common element of both sets. We have the person who loves swimming and football. So if you notice, the word that I'm using for intersection is and. Love swimming and football. So our answer would be June and Ben, because June is here as well, Ben and Ben. So this is now a new set. That's why it's so called as an operation. Just like operations and numbers, once you have a plus, for example, 2 plus 4, there are two different integers, but when you perform the operation addition, it gives us a new number. So just like here, intersection is an operation between two sets because it gives us a new set, which has an element June and Ben. Let's go back now to our situation a while ago for us to know the second set operation. If the question this time is, if Sandra and Marco combine their fruits, what fruits do they have in all? It's like putting together all the fruits in one. So that would be apple, orange, pineapple, mango, and banana. So when we try to put them together, we are already performing the second set operation, which is so-called as union. So the union of sets A and B, written as this one. So this one is already the symbol for union. So A union B is the set of all elements that are in A or in B or in both A and B. Just remember, the keyword this time is the word or, for you to easily identify if the word problem is trying to ask you to find the union. So again, what makes intersection and union different from each other? Intersection is the commonality of both sets, while union is putting together all the elements in both sets. In the Venn diagram, the union exists in all regions inside the circles, but not inside the rectangle. That's why everything is shaded inside, because you are trying to consider all of the elements that is present in the circles. So for example, if we have here two sets A and B, we have A containing the elements 2, 3, 4, and 5, and set B containing the elements 3, 5, and 6. So we are now asked not the intersection anymore because intersection would look like this, but this one now is A union B. So we need to write them together or put them together. So we have 2, 3, 4, and 5 from set A, and then an additional is 6. Now, when you try to combine, you should not write 3 twice. Remember, set is about distinct objects. There's no need for you to write 3 twice, or even the 4 and the 5. To write it once is enough. So our answer for A union B, or we can read it as the union of sets A and B, is 2, 3, 4, 5, and 6. So, what are union and intersection? As I said a while ago, these are set operations because they replace two sets with a third set. So going back to our operation on integers, if we have 5 times 6, so the operation is multiplication. We have 5 and 6 as our integers. When we perform, we were able to combine the two, replace it with a new number, which will become 30. And now, same concept. When we perform union or intersection, we will be able to come up with a new third set out from the two sets that we have. So let us try some practice example. So we have here A intersection B, but you're given with three sets, so we have to be careful what set would you use to perform the operation. So A and B, the operation is intersection. You're looking for the commonality between the two sets that is present in both A and B. So what are those numbers? We have 2, we have 4, we have 5, and we have 6. That means the answer is 2, 4, 5, and 6. Now, for B intersection C, we're still looking for the commonality between the two sets. So, what are those? We have we have in B, there's none, there's no 2, there's no 4, there's no 5 in C, there's no um but there is a 6 as you can see. Therefore, that's our intersection. Don't forget to enclose it in braces because this will signify that there is a new set created out from the operation of two sets. Now let's try to determine the union of the following sets. So we have here set M and set N. So that would be M union N is equal, don't forget, equal to in the braces. You start from -5, -4, -3, then -2. But no need to write -2 again because you've already write it here. -1, 0, 1, and 2. So which of the given subsets are disjoint sets? Okay, that's our question. Remember, this is our universal set, and we have subsets here, which are A, C, and B. Okay, so let's try to compare A and B. If you will see A and B now, that's 2, there's no 2, 3, there's no 3, 5, there's no 5 in B, but there is a 6. Therefore, A and B are not disjoint sets because they have something in common. How about A and C? No 2, no 3, no 5, no 6. Therefore, A and C are disjoint sets. So initially, we have A and C as an answer. Okay? And then, how about B and C? No 6, but there is 7. So that means B and C are not disjoint sets because they have something in common when you try to find the intersection. So our answer is sets A and C are disjoint sets. Okay, now let's proceed to our third operation. We call it as difference of two sets. To define the difference of two sets, the difference of set B and set A is denoted as A minus B is the set of elements in A but not in B. So this is the area for the difference of two sets, the difference of A and B. That signifies that we're only referring to the elements that are in A but not in B, or in other words, A only. So again, the word only is very important in our study because we will be using that all the time. So remember, if you encounter the word only, let's say A only, that means elements that are here in this region only, but not in the other set. If, for example, if this one becomes B minus A, or the difference of B and A, that means you're looking for what is in B only as well. Let's try some example. We have here A and B. These are about Sandra and Marco again. So when we are asked about the difference of A and B, that means that we're looking for the elements that are in A only. So looking at the situation now, it's apple and mango is not. So you will not include that, but banana. So again, not mango because as you can see, mango is also in B. So our answer is apple and banana only. When we're asked about the difference between B and A, that means that we're looking for the elements in B only. So looking at B, which is not in A, we have orange and pineapple. Let's have another example. We have here two sets written in set builder notation. X such that X is a counting number between 3 and 8, and X such that X is the whole number less than 6. When we do set operations, it is easier for us to come up with a third set if it's written in raster notation and not in set builder notation. So the very first step that you need to do is you have to write it in raster notation. So for A, what are the counting numbers between 3 and 8? So that would be 4, 5, 6, and 7. While in B, whole number less than 6. So remember, whole number starts at 0. So don't forget 0, 1, 2, 3, 4, until 5. Because it's less than 6, that means 6 is not included. That's the time that you have to find the difference between A and B and A. So let's begin by finding first the difference between sets A and B. So meaning, we're looking for the elements that are in A only. So the elements that are in A only are what? Not 4, not a 5, but 6 and 7. So that's our answer. And then for the difference of B and A, elements that are in B only. Okay? So what are the elements in B only? So we'll look at this one. Elements that are in B only are what? 0, because there's no 0 there in A. 1, 2, and 3. Because you don't see 0, 1, 2, and 3 in A. But not a 4, not a 5, because it's also in A. So that means the answer is 0, 1, 2, and 3. Okay, this would be the last operation. We call it as complement of a set. So let us try to consider a new problem this time. The school trains five students: Paul, Eileen, Jonathan, Tina, and Erwin for the math challenge. For the actual competition, the school sends only the top three. So suppose Paul, Eileen, and Tina were selected for the competition. Who were not selected? So I guess your answer would be what? Your answer, I would guess, your answer would be Jonathan and Erwin. So if we will try to translate the situation now in our topic, we can actually write all the students that were being considered in our as our universal set. Because for the competition, our choices are Paul, Eileen, Jonathan, Tina, and Erwin. And then we will represent set A, the subset coming from the universal set, um, as students who were selected for the competition. So we have Paul, Eileen, and Tina. So the sets who were not selected is usually referred as the complement of those who were selected. So now the symbol for the operation complement is like an apostrophe. It's here. So that means the complement of set A. That's how you read it. It's a set of elements in a universal set that are not in A. So you are comparing um, it from our universal set. You are trying to figure out who which elements are in universal set, but not in the set that we are considering. In our case here, we don't have Jonathan and Erwin in A. That's why the complement of set A is Jonathan and Erwin. If we will look at the Venn diagram, the area for complement of a set is outside the circle because again, what we are looking for here are elements that are in the universal set, the elements that are being considered in the situation, but not either in the two subsets that we are having. So here, the yellow region is where you will place those elements that are being considered in a universal set, but not in our A or B. So when we try to find the complement of each set, for example, set B, we have elements 1, 2, and 3. You're looking for the elements that are in U, in the universal set, which are 5, 8, and 10. So this is how we write our final answer, complement of B, containing the elements 5, 8, and 10. How about for C? What's the complement of C? So we have a 1, but there's no 2. Allow me to use another color. Okay, but no 2 in C. There is a 3 here, there is a 5, there is an 8, there is a 10. That means the complement of C is 2 because it's in the universal set but not in C. Let's try some other practice examples. So every time you will be asked about the complement of a set, the universal set should be given to you. Okay, so we're asked here what's a complement of set A if this is our set A. So looking at the situation, there's no 0, there is a 1, there is a 2. There's no 2, I mean. So that's an answer. That will be part of our answer. 3 is here. There's no 4. There's a 5. There's no 6. There is a 7 in here. But there's no 8 and 9. That means that the complement of A is 0, 2, 4, 6, 8, and 9. Okay. Now, this is the other symbol in other books for complement. So it's like a letter C. As an exponent, it's like an exponent. So that means you're looking for the complement of this set having 2, 4, and 6. So still, we're comparing it to our universal set. So you have no 0 here, no 1, but there is a 2, but there is no 3, there is a 4, there is no 5, there's a 6, there's no 7, 8, and 9. And that would be our answer here. The new set this time would be 0, 1, 3, 5, 7, 8, and 9. And lastly, the complement of this set containing 0, 5, 8, and 9. So let's try to use another color. Let's say orange. So there's a 0, there's no 1, there's no 2, there's no 3, there's no 4, but there is 5 now. There's no 6, there's no 7, but there's 8 and 9. So that means 1, 2, 3, 4, 6, and 7.